Hello, so today we will be discussing some common assumptions in linear regression. So a couple that I want to highlight today is autocorrelation and multicollinearity. It's a tongue twister. So autocorrelation is basically the idea that no data point is reliant on the data points that came before or after it. And multicollinearity is basically highly correlated variables. So we can use the ordinary least squares to determine whether there is autocorrelation and multicollinearity. So we're going to continue to look at the model I used previously for correlation and causation. So we're looking at income, education, and savings levels. So as we generated this random data set, we looked at the correlation just because we want to see the autocorrelation. We don't have to do this step. It will be provided in some of the summary below, but just continuing on that path, we see that there is a positive correlation between income and savings, and the p-value is much less than 0.05, and so that means it's statistically significant. So as we look at the heat map to see those correlation coefficients, we see that education and income are highly correlated. Income and savings are positively correlated, as well as education and savings are positively correlated as well. So now we're looking to generating multiple linear regression to predict savings. And because we're predicting savings, I put that as the dependent variable. And income and education is our independent variables. And I set a constant so that it could account for the intercept. So I'm using, again, the ordinary least squares here on the fit model. And we'll print out that summary. And as you can see, the OLS regression results has a ton of data, some great data. However, for the sake of the example, we're going to look at those that relate to autocorrelation and multicollinearity. So to determine autocorrelation, we will first look at the Durbin-Watson measurement. So this measurement basically is used to indicate autocorrelation. It ranges from 0 to 4. 2 means there is no autocorrelation. If it's more than 2, there is a negative autocorrelation. If it's less than 2, then there's a positive autocorrelation. So as you can see here, it is more than 2. So there is an indicator that there is some autocorrelation. And for multicollinearity, we'll look at this condition number. So the condition number indicates whether there is multicollinearity. Anything over 30 suggests that there is multicollinearity, and this condition number is a huge number, so there is indeed an indicator of multicollinearity. So we'll continue to see just how this looks. I put it on a scatter plot using income and savings and colored it by education level. So we'll look at that. So as you see, savings is on our y-axis, income is on our x-axis, and there is a positive correlation as savings increase. So this income. So we can see it moving up to the right positively. And as we factor in education level, the lower level is dark blue and it transitions to a lighter blue, to a faint color here in the middle, then it transitions to a lighter red, and the highest level is a darker red. So as we can see, the blues actually start out on our left, which is our lower education levels, and they increase to reds. So again, this shows that there is correlation within these variables. So hopefully that makes sense.